The CMMs are located in the metrology lab, downstairs in the Ross Engineering Building, room 139. Before you start, always make sure that the probe is clear of unwanted obstacles whenever measurements will be taken. The jog box diagram is located on the table next to the CMMs. To begin, open the air valve and power on the CMM controller. The air valve is located in the front of the CMM and the switch for power is on the back side. Next, clear the e-stop by pulling and twisting the large red button on the jog box. Then press the machine start button. Log on to the computer closest to the CMM. Then open the PC Demus online software. For CMM 1, use tip 1. For CMM 2, use tip 2. Verify that obstacles are clear of the measurement probe. You may need to press machine start again if there is an error. Press OK. Select File, then New to create a new measurement program. Name your file accordingly, verify the unit is correct, and then press OK. In the Probe Utility dialog, select Tip 1 from the Probe File box, then select the tip in the active tip list. Press Measure. Ensure that MAN plus DCC calibrate tips and default mode are selected, then press Measure. Press Yes to measure all tips. Select Yes, manual hit to locate tool, then press OK. Select OK to acknowledge the warning. Take a single probing point on the top of the calibration sphere located at the back corner of the CMM table. Press Done on the jog box to allow the CMM to complete calibration. Press Continue to finalize the tip calibration. Select View, then press Command Mode to change from Summary Mode. Resize the edit window so you can view all of the text. You are now ready to probe. Using 15 widely spaced hits, probe the top flat plane of the demo block. Then push Done on the jog box to identify the feature in the window. You can rename the measurement by double-clicking on plane A. Create a line, take 3 hits on any flat surface. Then press Done. Line B will appear in the edit window. To create a point, use 1 hit on any surface, then press Done. A computer alignment must be created to position and fix the part in 3D space by eliminating all 6 degrees of freedom, translation in X, Y, and Z directions, and a rotation about each of these 3 axes. The 3 features created prior will be used to create an alignment ABC by identifying the appropriate feature for each of the following. Level, whichever feature constrains 2 of the 3 degrees of freedom, a 3D feature. Rotate, whichever feature constrains the remaining degree of rotational freedom, the 2D feature. And origins, features that constrain translational degrees of freedom and establish origins. Confirm that the location of the text cursor is at the bottom of the text. Then select Insert, Alignment, and New. Select the appropriate feature, then select Level to set the level. To set the rotate, select the appropriate feature, then press Rotate. To establish an origin for each of the X, Y, and Z axes, check an axis, then select the appropriate feature and press Origin. Repeat this step for each axis. Change the alignment ID to ABC and press OK to exit. To display the probe coordinates and the amount of hits on the current measure, press Ctrl W. To create a circle, collect 4 hits at the same Z value within a circle, and then press Done. To create a cylinder, collect 4 hits in a circle at one Z position. Then move to a new Z position and collect 4 more hits. Press Done once completed on the jog box. To create a line, collect 3 hits on a surface at one Z position. Then press Done. To create a location dimension, select Insert, Dimension, and Location. Highlight the desired features, select Auto under Axis, press Create, and close the dialog box. Observe the results in the Edit window. Update the nominal values from the drawing, and say Yes to carry back to Features, and check Don't Ask Again, and say No to change Hit Match to Theoretical, and check Don't Ask Again. To create construction circles, select Insert, Feature, Constructed, and Circle. Select the desired measured geometry, press Create, and close once finished. To generate a report, select View, then Report window. To create a datum scheme, select Insert, Dimension, and Datum Definition. Then apply the appropriate features to each datum. To recreate drawing GD&T, select Insert, Dimension, and then the appropriate callout. Apply the correct tolerance from the drawing and datum reference. To print the report, select File, Printing, Report Print Window, and select OK to print in the location listed. To shut down the system, log off the CMM computer, press the E-stop, power down the controller, and close the air valve.